Okay, so for this video, we're going to talk about another derivation of a kinematic equation. So what we're going to do is we're going to describe, or combine average velocity and the final velocities equation. This is the second and third equation that we discussed in the previous video. So this derivation of the formula is very important, or is very useful. We're going to describe the velocity using acceleration and distance. Okay, so to start with, we have this one. Again, these two equations are for constant acceleration. Sorry. So for this equation, we can describe, again, this is your average velocity, so we can describe average velocity using the function x, or your distance. So instead of using average velocity, we can say x over t. So x over t is still your velocity over v sub f plus v sub o over 2. So we're just going to isolate your velocity. So that means we need to multiply both, or the equation by 2. So you will have 2 times t over t is equal to vf plus vo. So that is how you're going to describe velocity. This is actually your velocity. Final plus initial velocity. This one is also velocity, x over t. Okay, so next we're going to combine this equation with this equation. So what we're going to do is we're going to multiply them. So let's just make sure that I'm just going to rearrange the equation, so that will give us vf plus vo is equal to 2x over t. I just rearranged the equation so that when we multiply this one to this equation, we will have all of your velocity in the left side and the other variable on the right side. So I'm just going to transpose this on the other side. So vf minus vo is equal to 80. So this equation and this equation are the same. Okay. Next, so multiply this one. So multiply this. And next is you're going to multiply this one also. So you will have vf plus vo multiplied by vf minus vo is equal to 2x. So this x, that is actually your initial and your final distance. So you can express this one as the change in displacement when the object is traveling or is moving. So instead of using x only, you can also substitute this one by xf minus x sub o. Again, this is the change in distance when the object is moving. Okay, multiplied by 80. Okay, so as what you can see here, t is in the denominator and other t is in the numerator. You can cancel this one. So instead of adding 80, t is cancelled out. So in the other side of the equation, what you will have is only 2 times x sub f minus x sub o times a. To simplify this one, you will get vf squared minus v sub o squared is equal to 2a, which is your acceleration, x sub f minus x sub o. So your final velocity would be Vf squared minus Vf squared is equal to Vo squared plus 2a multiplied by x sub f minus x sub o. Okay, so this equation, you're describing velocity using the function acceleration and distance. So this is very important or useful, especially in the work kinetic energy theorem.